Hi everyone, today's class is about establishment of tool data. Tool data is used to describe the TCP, mass, center of gravity, and other parameter data of the tools installed on the 6th axis of the robot. Generally, different robots are equipped with different tools. For example, the arc-welding robot uses an arc-welding gun as the tool, while the robot used for transporting plates uses a suction cup as a tool. The tool center point, TCP, is located in the center of the industrial robot flange, the original TCP of the industrial robot. The principle of setting TCP data for industrial robots is as following. Firstly, find a fixed point within the working range of industrial robots as a reference point. Then, determine a reference point on the installed tool of the industrial robot, preferably the center point of the tool. Use the method of manual operation in previous classes to move the reference point in the tool. Make the robot fit as closely as possible with the fixed points in 4 different movements or happen to attach. To obtain more accurate TCP, the following example will be the 6-point location. 4-point location means that make the reference point of the tool perpendicular to the fixed point. 5-point location means that make the reference point move from a fixed point to the x direction of TCP. 6-point location means that make the reference point move from a fixed point to the z direction of TCP. The robot can calculate the TCP data through the position data of these 4 points, and then the TCP data will be saved in the tool data program data for operation. When executing the program, the industrial robot moves TCP to the fixed position. If you want to change the tool and tool data coordinates, the movement conducted by the industrial robot will also change accordingly. All robots have a wait for set tool data coordinate at its wrist, which is called the tool 0. 1 or more new tool data coordinates can be set tool data for tool 0's movement. The tool data of industrial robots can be established in 3 ways, including the 4-point location, the 5-point location, and the 6-point location. The 4-point location does not change the coordinate direction of tool 0. The 5-point location will change the z direction of tool 0. The 6-point location will change the x and z directions of tool 0. The last one is common in welding applications. When obtaining the positions of the first 3 points, the greater the distance between their positions, the higher the accuracy. In industrial production, industrial robots for mechanical processing, laser cutting, and welding require high accuracy of tool data. Precise TCP can ensure that industrial robots achieve higher accuracy in mechanical processing and laser cutting. Therefore, when determining fixed points, it is necessary to make sure precise fixed points of TCP in order to obtain precise tool data in the operation. The following is an example of the 6-point location, which describes the steps for establishing the tool data. At this time, the working mode of the industrial robot must be manual mode. Step 1. Click on Manual Manipulation in the main menu. Step 2. Click on Tool Data Coordinates in the Manual Manipulation. Step 3. Click New Ellipsis in the lower left corner. Step 4. Set the tool data and click OK. Step 5. Select the name of the tool data created by the operator. Click the Define Ellipsis option in the Edit menu. Step 6. Select TCP and Z and X to set TCP by using a 6-point location. Step 7. select the appropriate manual operation mode and use the joystick to make the industrial robot tool reference point up against the fixed point as the first point. Step 8. Select point 1 and click Modify Position to record the position of point 1 as the current point position. Step 9. Change the tool movements at reference point closer to the fixed point. Step 10. After the tool point position is determined, switch to the tool coordinate definition. Click Modify Position to record the point 2 position. Step 11. The tool reference point transformation leans up against the fixed point. Step 12. Click Modify Position to record the position of point 3. Step 13. Transform the tool movements at reference point to lean up against the fixed point. This is the fourth point. The tool reference point should be perpendicular to the fixed point. Step 14. Click Modify Position to record the point 4 position. Step 15. The tool reference point moves from a fixed point to the positive plus X direction of the tool TCP in the point 4 movement. Step 16. Click Modify Position to record the extender point X position. Step 17. The tool reference point is moved from the fixed point to the plus Z direction of the tool TCP in this movement. Step 18. Click Modify Position to record the Z position of the extender point and click OK to complete the setting. Step 19. Confirm the error. The smaller the better, but also subject to the actual verification of the effect. Step 20. Select Tool 1 and choose Change Value in the Edit menu. Step 21. Set the tool's mass and center of gravity position data based on actual need, and then click OK. Step 22. Select Tool 1 and click OK. Step 23. The action mode is selected as Reposition. The coordinate system is selected as Tool, and the tool coordinates are selected as Tool 1. Step 24. Use a joystick to bring the tool reference point up against a fixed point, and then manually maneuver the robot in repositioning mode. If the TCP is set accurately, you can see that the tool reference point is always in contact with the fixed point. The industrial robot will change its movements according to the repositioning operation. Here, we are done for the setting of the Tooldata TCP. Handling industrial robots generally have vacuum suction cups and grippers. These tools are generally installed on the industrial robot flange. Take the vacuum suction cup as an example. Tooldata only need to set the tool mass, the center of gravity, in the default tool 0's plus Z positive direction offset value. TCP is set in the suction cup on the contact surface from the default tool 0 on the plus Z direction offset value. Assumptions. Tool mass is 20 kilograms. Center of gravity is 200 millimeters. In the positive direction of plus Z on tool 0. TCP point is 350 millimeters, offset from plus Z on tool 0. To set the tool data for the vacuum chuck on the demonstrator is as follows. Step 1. Select tool data coordinates in the manual manipulation. Step 2. Click New in the lower left corner. Step 3. Set the data as desired and the initial value of the stand-alone machine to the newly created coordinate data. Step 4. The TCP is set on the contact surface of the suction cups at the default tool 0 of this with a 350 mm offset in the positive direction. Step 5. The mass of the tool is 20 kilograms and the center of gravity is shifted by 200 mm in the plus Z direction of the default tool 0. Set the values and click OK. Here, we have done for the setting of the data for suction cups. Okay, that's the end of the class. Thanks for watching.